Okay, here we're going to look at how to import the field data that we've collected and have it formatted for modeling fire behavior with frame. First of all, we start out with the frame function, and also dplyr and vary functions will be needed for this. To import the data, we have that data entered as two CSV files, so let's import those and have a look at them. Survey data, the site field here, I've given a number for each transect. In this example, there are 2 transects that I've used, calling all of these transects tuit because it's from a site with tuit trees in it. At each point along the transect, each 5-meter mark, I've recorded the number, the point along the transect there, and for each of those points, I've recorded the species intercepted in the vertical transect. So at the first point, there was an Agonus flexuosa. It's got a base height, a top height, and a width. I haven't recorded the height of the lower edge and the top edge of the hexagon because I'm just going to use a simple rectangular format for them here. In some sites, there are 2 species recorded because there were overlapping species. If we look at the traits, we have each species listed here. Same spelling of the name. That's important to check your data there for spelling errors. This is the proportion data value between 0 and 1. Leaves can be either flat, as in a usual leaf that you're used to seeing, or round like a terete leaf or a needle. These dimensions, leaf thickness, leaf width, and leaf length, also leaf separation, are all in meters. Stem order is an average of a few different measurements. That was stem order or ramification. Ignition temperature. If you don't know, just use the value of 260 degrees. This is the piloted ignition temperature. Some species, such as eucalypt species, will ignite at a lower temperature, like 220 degrees, because of aromatic oils there. It's a fairly loose relationship, but aromaticity is the best way to measure that. Leaf moisture is just in a whole number value, so 100% oven dry weight is just a value of 1. Sorry, it's not a whole number value, but it's a proportional value. SUSP NS refers to suspended near surface litter. So these are sticks and bark and leaves that are close to the ground. It's 100% dead and very dry, only 5% moisture. Then the gap to clump ratio in each of these, and the clump to canopy size ratio, as we looked at in those diagrams. So there are 2 options of using that data that I'm going to look at, because there were 2 transects there. The first option is to only consider 1 transect at a time. So if we filter down to just transect 1, we can see that transect 2 has been dropped off. Now, to process that data, we're going to use this function frame survey. What frame survey calls, if we have a look at the help for the frame package, there are a number of default values that fall in there, but so we want the name of the data set, which is site 1, the name of the default species parameters, which is traits. This value surf is the weight of surface litter in tons per hectare. The cover value here, we can see, is the percent cover of the suspended layer, so that's suspended near surface litter. And in this case, we'll say that there is no suspended near surface litter. So if we run that function, what it's done is gone through and filled those empty values of the height of the top and the height of the edge of the hexagon and clearly made that into a rectangle. First table is the Flora table here, and what we can see is we have this field stratum. So every species that we measured in that transect is listed here, but we have this new field stratum. What has happened there is that we've used some clustering algorithms to have a look and see how those species are arranged based on the frequency of their occurrence and the dimensions of each of those plants. And so, for example, in the lowest stratum, we've got two different xanthorrhoeas and an eryngium, and we have average dimensions for those base and top heights of those. If we look at the second stratum, we can see that the plants are consistently taller, and again in the canopy, much taller than those. We can also see a standard deviation in the range of top heights, and this is the range between the upper and lower. So there are some functions in fire modeling that we'll look at later where we can randomly vary plants within that range using a mean top height and a standard deviation as listed here. The weight value here refers to the weight of surface litter, and this is the average diameter of the surface litter, which is in this case 5 millimeters. That's the default value. So surface litter is usually measured up to 6 millimeters in diameter. Most of that weight is in, of course, the larger fragments of it. So what I've done is used a default value that is just below 6 millimeters. The second table is the structured table, and what that gives us is a row for the whole site there. So we've now divided these strata, named the strata into near surface, elevated, mid-story and canopy. There was no mid-story stratum, so that gets an NA value. But these other values here are the average distance between plants in each stratum. These fields look at whether one stratum overlaps another. So do near surface plants grow beneath elevated plants? No, they don't. There's no mid-story, so both of these fields are obsolete, but the elevated plants also don't grow beneath the canopy plants. These values here refer to the species richness in each stratum. So there was 3 species in near surface, 2 in elevated and 2 in the canopy. The final stage is to build a parameter file to run the model and then run that model here as with FFM run. So the parameter file, we need to tell it the name of the structure table and the Flora table, the name of the traits table, and which record we are using. And we're also going to give it the length of the fire line. This influences fire behavior, as very short fire lines can reduce rates of spread and flame heights. So if you run that, we get a table produced. We'll have a quick look at that table for site A, and it's just a slight rearrangement for each species. We start out with a stratum, and within that stratum there can be more than one species. The species is named and all of its different structure and flammability traits are listed beneath it. And finally at the end of that we end up with details on what's overlapping. For each stratum there's the spacing between plants, there's the fuel load in tonnes per hectare, and we've also got a few default values here of weather parameters, which I'll show you in a later module how to set specifically for your sites that you're studying. So does this run? It's calling a Java function, and the true value here tells it that yes, it has run, and it has output the data to a database that we've called sa.db. We won't look at that until the next module. A second option is to actually combine the two transects into one long transect and better capture the diversity at the site. We might use option 1 to look at the difference between fire behaviour in the two transects, but if we want to get a more representative measure of fire behaviour across the full area there, we can combine both transects together using this function transect long. So if we run that, what we get now is all of the values, but instead of having two transect names there, they're all called transect 1, and these point values are now added on, so we've got one 100-meter long transect. We can then again go through that same process of creating the tables. It's filled in those empty values there now, but there are twice as many. We can create the two separate tables for Flora and structure, build the parameters folder as we did before, and then run that. And as we can see, it's worked again.